Assalamualaikum and hi. I represent for my group Spectrum want to talk about sight without visible light. So, human granted with the ability to see with their eyes. Without visible light, are we able to see the things around us? So, first of all, what is visible light spectrum? Visible light spectrum is the segment of the electromagnetic spectrum that the human eyes can see. The human eyes only can detect wavelength from 380 to 700 nanometer. The reasons why human eyes can look at spectrum because of a specific wavelength at their retina in our eyes. Other sections of the spectrum wavelength are either too big or small, and energetic of beyond of our ability. Violet have the shortest wavelength, which is around 380 nanometer, while red has the longest wavelength, which is at 700 nanometer. Then next, corona is the outermost layer of the sun's atmosphere, can be seen in visible light. It only can be seen during the full solar eclipse while bright photosphere exceed it.
Hi, I'm going to talk about one of the most important part in our topic, which is how do we see without visible light? And one might argue that it's entirely impossible for us to see without visible light. But due to recent technological advancements, we are technically able to see without visible light. Imagine yourself in a pitch black situation in complete darkness. What kind of equipment or technologies would you use to help you or assist you in seeing the dark? Well, the first would come in mind would be night vision, right? So in my part, I will be talking about night vision. And in night vision, generally we have two of the most commonly used technologies, which is image enhancement and thermal imaging. So both of these share a similarity where they utilize infrared rays to form an image to be more perceivable by the human eye. So you might ask, what is image enhancement? Well, image enhancement is basically amplifying low intensity ambient light and near infrared rays which are close to the visible light spectrum to form an image which is more visible to the human eye. So in this case, we could see the basics of the working principles of image enhancements in night vision devices as shown in this diagram. And this is the flow of how infrared rays form an image through the eyepiece lens. Well, you might ask, what is thermal imaging? Well, in order to know that, we must know that every matter above absolute zero has thermal energy and radiates some form of infrared rays. Well, thermal imaging utilizes those infrared rays to form image due to a variation of different temperatures of different objects. And I'll show you the basics of the thermal imaging in night vision devices, as you can see right here. So the summary for my part is both of these technologies are well established and well developed. And you can see both of these technologies are often used in military service for surveillance or even implemented in safety features of a vehicle to detect objects in complete darkness or in the night. Well, that's all from me. Thank you.
Hello, Assalamualaikum. My name is Zul Aiman Afifi bin Muhammad Asri. So today, I want to explain how people can see with sound wave. First of all, I want to explain how it produced. Sound waves are produced by vibrations. When sound waves are vibrate, it moves forward through the medium, creating compression and refractions. So, when air particles vibrate, it causes your eardrum to vibrate. Louder sound is produced when the vibrations become bigger. Then, we can hear people whispering nearby. There are three types of waves: longitudinal, mechanical, and pressure wave. And this is the example of how this wave was progressed. Longitudinal wave, mechanical wave, and pressure wave. So, all the progress of this wave can help us to detect something was close to us, even in the dark. So, in conclusion, we are be able to see even there is no light around us. With the support of advanced technology that follows the concept of physics, it's not impossible to make us do something incredible, such as see something in the dark. That's all from me. Thank you.